Hi everyone, I am Dr. Lipsa Mishra, working as Assistant Professor in Madnapalli Institute of Technology Science in the Department of Civil Engineering. So today we are going to see the content about the water treatment. So first of all, I want to tell you what is the sources of water. What are the sources of water? Basically, it may be surface water, it may be subsurface water. So what are the surface waters? We can see like rivers, lakes, springs, and all these things. These are the sources of water of surface water. And subsurface sources like well, springs, bore wells, all these are the subsurface sources. So is it okay to directly drink the water from the source, direct source? No, right? Because the water may be contain some impurities, some pathogen bacteria, or some heavy metals, or some different types of impurities. So that need some. First, we will see the what are the characteristics of water. So that is we'll see that is water quality. So basically, it may be three types, that is physical characteristics, chemical characteristics, and biological characteristics. So, what are the physical characteristics of the water? Basically, like temperature, taste, and odor, and turbidity, and uh, and the suspended solids. So, what are the suspended solids present in water? In maybe in three types. That may be um, in suspended form, that may be in colloidal form, and that may be in dissolved form. So, those are the physical characteristics of water. We can taste and smell, and the odor, that may be, if that is bad, that we can say that is the not a good water or drinkable water or potable water. Similarly, the temperature should maintain not less than 4 degrees centigrade and not more than 35 degrees centigrade, so that we can say that water is good. Similarly, we'll see next, that is chemical characteristics. What are the chemical characteristics? Basically, that is pH of water, that ranges from 0 to 14. That 0 to 7 or 0 to 6 is called acidic nature, acidic water, and 7 is the neutral, and beyond 7 to 14 is called alkaline water. So basically, the as per the is code for drinking purpose, is code 10500, it mentioned that 6.5 to 8.5 is the uh, uh, permissible limit for the pH of the water. Means that is the uh, safe drinking water pH. And similarly, the hardness, the alkalinity, and some chemicals like chloride, some heavy metals like chloride, fluoride, and iron, all these having some permissible limit which are mentioned in the is codes. So those permissible limit means that beyond that limit it is not drinkable for safe drinkable water, because it may harmful to our health. So similarly, some biological characteristics follows, like some bacteria, some pathogens, some fungi may be present in the water, which may be from some waterborne diseases like diarrhea, cholera, all these things, typhoid. So we need a treatment for that one. So that is, that may be some E. coli may be present, some pathogens, or some uh, so for that we need some taste. So we can see what are the characteristics of and what are the sources of water. So from physical properties like odor, color, and the solids, as I told you, so these are the sources of water and the characteristics, basic characteristics of one water or quality of water before we are going to drink for drinking purpose. So, before going to drink or provide the drinking water to your home, we need some treatment. So, what is the treatment process of water? Basically, from the river or from the intake or the source directly, from the pump, we can uh, pump it and to the water treatment plant. So, first step is the screening. Okay, first step is screening, and next is coagulation, then sedimentation, filtration, then after disinfection, and then we can store it with this storing storage tanks, then the distribution process are done by to your home. So basically we will see now one by one what are the treatment process, what is the first stage of the treatment process, that is called screening. So what is screening? Basically it removes the large suspended particles or the floating matters which are like polythene bags, racks, or the plastic things. So all these floating materials are easily removed by this first stage of the treatment. Like this may be the screens are maybe two types, that is coarse screen and fine screen. So coarse screen is nothing but the these inclined bars are having 25 diameter and 100 spacing, which prevents the large floating materials. So all these screens are generally placed in with angle of 30 to 60 degree. Why? Because so that they require increase the cross sectional area, so that all the heavy floating materials can be attached to that, and the reduce of the velocity also, they can the flow of velocity can be reduced. That's why it placed with an angle. Then one fine screen also there, and this has having a very small pore size, or this is having the diameter of less than 10 so by applying this screening, we can remove all the heavy floating materials or suspended particles by this stage. Then next is the sedimentation. So sedimentation is nothing but it is the one more important treatment process, so that all the suspended and colloidal and dissolved particles can settle to the bottom by the force of the gravity. So this is the basic principle of the sedimentation process. We can see in the figure in that there is a mud water. After some time, or after we'll stir it and keep it for some time still, then the all the mud can be will be settled on the bottom of the tank or jar. So this sedimentation process may be of two types, that is one type one is plain sedimentation, and another one is sedimentation with coagulation. So sedimentation in plain sedimentation is nothing but there may be various types of tank according to the design. So design part we'll discuss it later. So what how we'll design the sedimentation tank, what should be the detention period. Detention period is not another important term in sedimentation tank. Detention period is nothing but the average time required to flow of the water and the settle of the particle at the bottom. So that is an important term that remember all of you, that is detention period, that denoted as small t. So how we'll calculate, how we'll design the sedimentation tank, we'll see in the next class. And this is the type 1, and type 2 is the sedimentation with coagulation. So what is coagulation basically? So coagulation is nothing but the adding of some chemicals. Suppose some suspended particles settle on the bottom of the tank, but some of colloidal particles may not settle easily because of the specific gravity less than to the water. So that's why it needs some chemicals, or having we are basically using alum, that is called Al2SO4 whole 3, the chemical name, that is alum. That if we add some chemical, that will make a the flock, or then it may be easily settle down to the bottom. So that we'll see in next slides, and next part, that is sedimentation with coagulation. So this is all about the two steps today we discussed, that is screening and sedimentation. So thank you.